Good day, everyone. Anyone who's listening, probably of the view that today we'll be dealing with wastewater. Now, the wastewater can be treated in many stages and many ways. But now, the stage that we are discussing today is preliminary. Now, when you speak of the preliminary stage, you are referring to a stage by which the main significant purpose of the stage is to remove your organic matter. Now, the organic matter that you are removing is the one that seems to be large enough not to be disintegrated. Now, when you speak of the disintegration, you are referring primarily to the breaking down of these organic matter through bacteriological action. Now, within the preliminary stages, the employment processes, the processes employed, we are referring to the screens as well as the grit removals. Now, when you speak of the grit removals and the screen, within the screens, of course, you will have different types of screens. Now, if you talk types of screens, you'll be referring to the manual operated screens as well as the automatic operated screens. Now, already, once you discuss about the manual operated screens, you know for a fact that you will be relating to manpower, and that is labor intensive. Now, when it comes to labor intensive, we know that the Department of Public Works is informed very well in terms of EPWP, which is Expanded Public Works Program, by which they believe in employing more men than machines. Now, also, the manual operated screens, they also depend on the size of the plant. Now, also the size of the plant matters because whatever amount of effluent that you have trapped in the manual operated screen, it gives you an ability to be able to then capture that. Now, if the plant is big enough, you would want to use automatic screens. Now, what happens in manual operational screens? Now, how does it work? Now, for instance, you take into consideration that you've got your own channel. Now, if that is your channel, there you will notice that your screens will be at an angle. The main significant reason why the screens are at an angle, it needs to be possible for gentle flow as well as easy for cleaning. Remembering that we're cleaning using a rake, so it needs to be possible for gentle flow and easy for cleaning. But another important thing, on top of the surface here, the surface is deemed to be perforated. Now, if the surface is deemed to be perforated, it literally means during the time by which you are cleaning your screens, you would put your screenings there. Why are you putting your screenings there after raking? Because your screenings are still wet, they are still combined with water, that are still wet in a wet form, then the small perforated holes there will then suck water back, and some of it broken down during the raking screenings back to the system. Well, the system is flowing in that direction, and then as it dries off, it is then collected to the bin. Now it will then be collected to a bin. Then once it's collected to a bin, what will happen is that those screenings will be disposed in various forms. But before we go to the screens and disposal in various forms, I would like us to also make mention of the resin. Now we need to resin now. We need to resin. The minute you start to resin, you think of one phase. Why? Why do we have screens and grit removal before the primary stage? Why do we have screen and grit removal before the primary stage? Number one, if you do not have the screens, that means there will be larger organic matter entering your system. Now, once you have larger organic matter entering the system, that means you anticipate the essence of blockages. There will be possibilities for blockages, and also there will be possibilities of abrasion. Now, if you've got blockages, you've got abrasion, this will result in impairing the treatment operation process. Your treatment stages will no longer reflect the same quality effluent as it was supposed to reflect. Right. Then, as we also mentioned with regards to our manual and our automatic screens, we understand that the manual is talking to a small plant and is also talking to too much of labor to be utilized. But the automatic screens are talking to machinery, as well as they are referring to a larger works in size. Right. If you talk these manual operational schemes and these automatic operational screens, what is it that you are referring to? Now, we're going to compare apples with apples now, just to see how these things are gelling. One, if you talk automatic, I will say auto this side, and then we'll say manual this side. Of course, yes, you would think of cars. If you think of cars, you will understand here that there's a lot of change of gears, and here there is no such. So they don't change gears in automatic. Now here you need energy to change gears, and here there is less energy required for changing gears, so there is less manpower required for operation. But if you look into the essence of the screenings, one, the screen itself, the bus screen, needs to be at an angle. That's what is important for cleaning purposes and so forth. But also, if you are looking at the automatic screens, it doesn't matter if it is vertically straight, at an angle, or skew, because there is no one who's going to rake. It's only the machine that it rakes itself. Here, you also make use of wheelbarrows. You make use of wheelbarrows for collection of waste, screenings, and then here there is no wheelbarrow. You might be using a conveyor belt. Now, a conveyor belt will channel the screenings to a channel where they are collected in, and then here you are channeling, you are picking it up through the wheelbarrow, and then you take it to the nearby bin, which is primarily for the screenings to be collected. Right. Let us say then, I've got this automatic, I've got this manual. Here, I know in manual that men will be told to go and rake, and they do operational rounds. But how do you know when to rake within automatic screens? Now, how do you know when to rake depends on entirely what is found. Now, the channel is in that fold and the screens are in that fold. Assuming that that is the level of water. Now, if that is a level of water, at normal circumstances, the level seems to be partially the same. But as soon as you notice that here you've got blockages taking place at the bottom here, and then if the direction of flow is in this direction, obviously the water level will rise from the upstream of the screen. Now, if it rises, the difference in level is the utmost determination as to activate the mechanical rake. Now, we need to identify the difference in level. We need to identify the difference in level of water before and after the screen, and then it gives us what needs to be done, which is, in this case, what needs to be done is to activate the rake so that you can automatically clean your screen. Now, that is referred, the activation of rake is referred to a storage degree. Stoppage degree. The degree at which the screen stops the flow in terms of rising before as opposed to after. Right. Tell me, as we are going through the explanation, what is it that you grasping? Of course, one would say, I can see that you are saying you reduce the amount of solids. In fact, the big solids. Yeah, you reduce big solids from entering the process. Now, if you reduce the solids from entering the process, that means you understand that the fact that there is spacing needed between those bars at your screen, which is between 20 millimeter to slightly maybe, I'm not sure, it might be 20 millimeter to 30 millimeter, it depends. Now, hypothetically, bigger space bar, allows the solids to go through, but the smaller space bars, the smaller space bars will be difficult to clean. Take into account that when you clean, you are using a rake, so if there's very small spaces between your bars, then that would mean your rake will not be flowing frequently well. Now, being it you are utilizing mechanical rake through a conveyor belt, which is in modern plants it's commonly used, and you can only activate it due to the stoppage degree. We've already explained the stoppage degree, whereby you measure the sewage level from both ends, and then the difference determines such. And also the screens at manual operation are always at an angle with advantages on that, and at automatic the angle does not matter. Okay, yes, we have collected now. We have collected screenings. We have collected screenings. Now, after we've collected screenings, what we need to do is to deal with them. Now, how do you deal with the screenings? Number one could think of disposing the screenings. But the element of disposing the screenings, first, before you can dispose, we would want to know one question. What would make these screenings to be different in volume, to have the difference in volume of that particular day? What contributes to the volume of the screenings per day? What contributes to the volume of the screenings per day? Now, this question is trying to understand if does a learner knows what really matters as far as the volume of the screenings. One would say the type of sewer matters. The type of sewage matters in the form of domestic as opposed to industrial. The domestic and industrial are dealt with in chapters 1 and 2 very frequently. Industrial. And also, what is it that else comes into action? It's the pre-disintegration. The pre-disintegration. Now, when you think of the pre-disintegration, you think of what has happened before the plant. The breakage that took place before the works on the pipeline. Now, if there was breakages, then there would be minimal screens, of course. But if there were no breakages prior to the disintegration, then there would be more screenings to be captured. And also, very important, your local development. Now, one says, how do you relate local development to the amount of screenings? I say, if you think of local development, you must come in part with recycling. Now, if plastics are being recycled, juice, bottles, juice bottles, and also it's juice bottles. It can be still objects, it can be paper, it can be cans, and so forth. Now, if this is in place, that means this is not visible within the screenings. It can be visible within the screenings because community people would have collected it and recycled it for money so that they could help themselves with either goods or services. And also the screen efficiency, which is number 4. Now, when you speak of the screen's efficiency, that means you are talking to the design. You are talking to the design. Now, the way of talking to the design, it's coming back to what we've already discussed here, which is talking towards the size, which is what millimeters, what height, what depth. Now, that generates the efficiency because remember we said the bigger the space bars, it will allow more solids, which is not what we want to pass through the primary treatment. And also the smaller the space bars, it will have difficult to clean through the raking system in manual or even mechanical, automatic mechanics in screens. Right. Going forward, we've collected the screens. Remember, we said it here that the screens have been collected. We said it there. The screens have been collected. Now, after the screens are collected, what else that needs to take place? You need to make use of them. You make use of them. Now, how do you make use of them? We already said you dispose them. But also, a reason for disposing screens depends. So the reason for disposing the screens depends highly on the size of the works as well as the location. When we explain the 3 methods of disposing the screens, at least you will be able to pick up where does the size of the works as well as the location fit into disposing the screens or dealing or making use of the screens. Right, when you dispose the screens, what is it that takes place? When you dispose the screens, what actually happens is, number 1, it's either you are burying them. It's either you are burying them, that means you dig a trench right across, you dig a trench, you lay your screens there, and then you do the backfilling. Now, after you've done that, that's that's it. Very cheap, very easy, very user friendly. But this happens only where there is land. Where there is land, one could say he associates the burial treatment of the screenings to villages, because villages have got more land. And also, the burial treatment can be access to villages. The minute you talk villages, that means you're going to talk less power. The minute you talk less power, you're going to talk to manual operated screens. The minute you talk manual, you're going to talk manpower. that constitutes to labor. Right. You can see we can go in circles when we explain this. And also, the second method is the incineration. The incineration is the second method. Incineration is the second method. Now, when you speak of incineration, you're going to speak of energy to burn. You want to speak of energy to burn. Where can we get energy to burn? Waste plants may produce their own. It's possible that the waste plants can be able to produce their own energy in order to exercise the function of incineration by which they are burning the screenings. What other methods do we have there? We talk of method 3, which is the disintegration. Now, this integration, understanding that if you talk of disintegration, you talk of breaking down into smaller particles through bacteriological reactions. Now, this breaking down in smaller particles come in the form of disintegration. But here, the form of disintegration, remembering the fact that these were our screens, this was the direction. Now we discover the screens here, and then we collect them to a spot here. Now, when we collect them to a spot here, they are all inside. We broke them down inside here. After we broke them down, we come in and channel them back to where the inflow is. Now, if you put them again where the inflow is, they will be conveyed through the flow, and most of them will manage to seep through because now they are in smaller sizes. And now there are type of organics that can be disintegrated. Right. So if this is the case as far as the disposing and also the taking care of your screenings, as far as the screens process is concerned, I think it does serve the purpose. Now we can see why is it important for us to have the screenings before we can move on to the primary treatment stage by which we are dealing with sedimentation tanks at most. Right, coming to grit removals. Now, what is happening with grit removals? Understanding that the grit removals may be controlling the velocity to circle the grit, but also you must take note that the specific gravity of the grit is at the ranges of 2.6, and the specific gravity of the organic matter is at the ranges of about 1.2. Now here, what velocity can allow settlement? Remembering that in grid channels and grid removals, we are trying by all means to make sure that the solids are settled as they are high in density and they are separated from water. But now, what is the velocity that can assist us in settling these solids? the velocity is a 0.3 meters per second. 0.3 meters per second. Now this velocity will assist us in terms of settlement of the high particles carried in suspension. Now let's say you've got this channel. Now one would say the best channel is to be in the form of a smile. Positiveness means smile. Yes, but now in this context we are referring to the smile because we are remembering that the best channel is in the parabolic form. Now the parabolic form, funny enough, if you look at the context of the design, it might look similar to a parabolic, but the structural deformation or the structural construction does not reflect such. Now this is the reality, and this is the plan to obtain the parabolic shape, but the reality is allowing us to construct it with corners, as we can see, trapezoidal shape kinda. Why is this? Why is the plan? Why the plan and the reality? Why? The main one is to say, if you talk of this plan, you will talk of easy ways to clean. Now it is easy and possible to clean, as same as it will be very easy to construct. It will be easy to construct and it will be easy to clean. Now, also, how do you know if your grid channel length should be? How do you know what length your grid should be? I always say, in order to promote circling at 0.3 meters per second, you need to adopt your length to be 10 times your depth of flow. 10 times your depth of flow. Now, say for instance, if that was the depth of the channel from there, and that was the depth of flow there, to be 1 meter. Now, if this is the case, the length of this channel will be reflecting a minimum of 10 meters. I hope you understand the calculation there. A minimum of 10 meters and also to a maximum of 15 meters. Right. So now, most designers, most engineers tend to design these grid channels in terms of two. Now, why would these engineers have channels in this form? Why would the engineers have channels in this form? Because one would say it could have just employed just one channel. If it has to be big, it must be big, and then it can close again. Just one channel. Just one channel need to be employed to cater for that volume, and that volume there will be that one. So if this one is A and this one is B, why A not B? here the flow is coming from that direction to that direction. Now, if for instance in this one that's coming directly like that, if for instance there is a problem somewhere here within this channel, that means there's a total shutdown. There's no process going to take place within the grid channels. But in this context, if there is a problem here, then this one would be shutted down, and then the flow will be conveyed on the other side. Now, in that context, it gives you that the alternation best suit for even the worst case scenarios when it comes to cleaning and maintenance. Alright, I understand we're talking much here. It sounds like it's too much, but it's just things that we already know. For instance, remembering the fact that we've already spoken about chapter 1 and chapter 2, which normally deals with the type of waste, the conditions why we treat waste, what type of designs and so forth. And earlier in the semester we were talking about the water treatment works, whereby we're dealing with lots of rectangular and circular tanks in terms of sedimentation. Even if you speak of the grid tanks, remember we said there are grid channels and there are grid tanks. Now if you speak of the grid tanks, you will still have to maintain the velocity again within the grid tanks, because this velocity is important for circling the high dense solids. High dense solids in suspension. Yeah, high dense solids that are carried in suspension. High dense solids that are carried in suspension. Yes, I think there was a slight disturbance there. We'll carry on with the class as we finish the day. Thank you.